Welcome, Calculus BC. This is lesson 1-4, limit definition, derivative, alternate form, and some trig review. Let's begin. So just want you to watch this GIF, or GIF, for a while. Notice I have this function here. We can call that function f of x. And we have 2 points on that function, point A and B. And point B starts up way up here, and then it's moving down and it's approaching point A. Well, and this is used to kind of demonstrate how to find the slope of a tangent line. So we have two things going on here. We have the concept of a secant line, which is a line that has 2 points on a graph. And so when the line starts off, when point A is here and point B is here, this is a secant line because it crosses the graph twice. Now a tangent line is a line that's going to cross at 1 point. So it starts as a secant line, and then as it goes down and these points are on top of each other, now we're a tangent. So the neat thing is that we're trying to find the slope of the curve at this point, point A. Well, to find a line, you need 2 points. And if you just use this 1 point, you can't find the slope of a line with 1 point. You need a second point. So that's why the secant has a slope, but really you can't do that when you only have 1 point. But what you have to do to actually find the slope of a tangent point is you take that secant and you just push those points even closer and closer until those points are on top of each other, and then you see that the line will actually form a tangent where it crosses once, and you can figure out the slope. So we use limit definitions to make this happen. Now I want to show you this again with some equations going on. So you start off where point A is at x f of x, and points H has this offset, this x plus h offset. So notice here that, and out here, so what does the h start at? Notice the h starts at right here, so that h is actually starting at h equals 2, and then it's shrinking, so all the way down it goes to h equals 0. When h equals 0, it's basically x plus h is equal to x. So this is where the concepts of limits come in. We start off at, basically you start off using the slope between 2 points, y2 minus y1, over x2 minus x1. We just write this in different form. Instead of saying y2 and y1, we say f of x plus h. So this is just like your y2. And minus f of x, y1. And instead of x2 minus x of 1, well, basically your x of 2 is just x plus h, and your x of 1 is just your x. Well, if you subtract those two, all you'd be left with is h. So our limit function is the slope between 2 points, but those points are approaching the same thing. That offset, which starts at 2, or wherever else, just 2 in this example, it's just being squeezed down to 1, and that's where you see this graph going on. So let's look at that a little bit more. Now here's a non-animated picture. Same idea here. You have this offset. Sometimes we call it a delta x offset instead of a plus h offset, but it's the same idea. I have this curve right here, and it starts off with this secant line that crosses twice, and then as it squeezes in, it forms this tangent line which crosses once. So the formula looks like just what we saw before. And again, I can use it as a delta x, this change of x, or I might say the plus h. You'll see both notations. This is how you find the slope of a line, which is the same thing as derivative. So hope the animation helped a little bit. Now, I know you know what a derivative is. You're in BC. So just a reminder, it's the slope at a certain point given a certain x value of the function, right? And we can write this in this f prime of x notation. But we might have other notations, y prime, dy dx. Sometimes you might see d of dx times a function. Or it's also called the slope of the tangent line. We also have this limit definition. And we didn't do this too much in BC, but we might have touched on it. But usually we didn't stress this or you had to do it this way too much. You just did your derivative formulas. For this lesson, we're going to actually use the limits to prove that it works. So just a note here, vertical tangent lines have no slope. That's just straight up and down. It's undefined, so no slope. Differentiation is the process of finding derivatives, and if a derivative exists, the function is differentiable at that point, and that comes in later. That comes in when we talk about like sharp turns. So let's do an example, and we're going to do this with the limit way, because I know you could say, hey, I can find the derivative and it's just 2x. Use the power rule. But let's use it using our derivative definitions. So it's going to be f of x plus delta x. In this case, if you plug in x plus delta x, it's going to be x plus delta x squared plus 2. All right? So I'm plugging that in. So I'm going to say x plus delta x squared plus 2 minus x squared plus 2, that's just your f of x, over delta x. All right, so let's simplify things. First thing, I'm going to expand this binomial. So it's a perfect squared, and that actually expands to x squared plus 2 delta x plus delta x squared. And then I'm going to say plus 2 minus distributing this minus sign, x squared and a minus 2, all over delta x. Well, combining like terms in the top, you are going to get this x squared and the x squared cancel, and the 2 and 2 cancel. So I have 2 delta x plus delta x squared over delta x. If on the top you factor out a delta x, I'm going to get delta x times 2 plus a delta x over a delta x. And then one of those delta x is going to cancel. So I can rewrite my simplified version of the limit as x of delta x approaches 0 of 2 plus delta. Oh, excuse me. I messed up in here. There should have been a 2x delta x. I messed up. So it should have been 2x plus delta x. And if you plug in 0 at this point, because before you couldn't have plugged in 0 because it would have been 0 over 0. That didn't work. Or you've been dividing by 0. That's bad. So if you plug in 0 now, that just comes out to 2x. Which, hey, I could have done power rule and been really faster, right? So I just want to show you can do this. Now I'm going to answer part B over here. Use the answer for part A to find f prime of negative 3. Well, you just plug in negative 3. So f prime of negative 3 is 2 times negative 3, which is negative 6. A. So yes, this is just to prove that you can do this, and it's good practice, but you're probably not going to do it this way a lot. All right, I can do these examples too, but I'll just save those for class. And let's talk a different form of this limit differentiation. So again, it's think of the slope between 2 points, y2 minus y1, or x2 minus x1. So this is just another way of saying this. And this is helpful like if you want to use limit definition at a single point. So you want to plug in a value for x. So think of it this way. Like C is that point I want to find. So I start off with some offset here, delta x, which is, you put your x value out here arbitrarily, and so your f of x would be out here. The change of x right here, so let's think of this as change of y over change of x. That's the slope between 2 points. Your change of x is just the difference between x and c, so x minus c. I can plug that in. And your change in y is just your difference of this f of x minus the f of c. That's just the difference right here. So I can rewrite my limit function this way. So this is useful if you want to use the limit definition and you want to plug in a point. So I'm going to do this for an example right here. So if I wanted to use the alternate form to find f prime of 3, so I'm going to say it's the limit as x approaches 3 of f of x. Well, I'm not going to say f of x. I can just plug that in. So I'm going to say f of x, which is going to be, in this case, x cubed, minus f of c, so f of 3, which is going to be 3 cubed, which is just 27, all over x minus 27. All right, so let's solve. I can just plug in the values at this point. I don't have to simplify. So I'm going to plug in 3, and it's going to be 27 minus 27 over 3 minus 27, which is 0 over negative 24, which is just 0. That's the derivative f prime of 3. Is that right? Oh, I know where I messed up. I'm not erasing. This wasn't minus 27 on the bottom. It was minus 3. So what you actually have to do is you have to factor the top. This is the difference of cubes. And it's going to be x minus 3 times x squared plus 3x plus 9. And it's same opposite plus for the signs. Look up the formula for that over x minus 3. We'd have some canceling. So we're always going to have some canceling. That's why this stuff actually works. So it's going to be the limit as x approaches 3 of x squared plus 3x plus 9. Now you plug in 3, so you're going to get 9 squared plus 9 is going to be 27, which is correct. Let's see if I did it the power rule way. I would say f prime of x equals 3x squared. So f prime of 3 is 3 times 3 squared, which is 27. Both ways work. One way was a lot more work. All right, we're going to save these for some later, and that's it.